Hello everyone, how are you all? Welcome to Chemistry Art. Myself Bhai Kumar Patel, and today we are going to discuss about the concentration of a particular solution. Okay, so as we have discussed about the Henry's law, it's a law for the gaseous solute dissolved into the liquid, and we have already discussed about the solubility for the solid also. So now very important term is concentration of solution, because without expression, how you can express the solution's concentration? Without expression, you will be not able to know that which is dilute and what is concentrated solution. Okay, so first of all, let me explain you what is diluted and what is concentrated solution. So concentration of solution means what? Concentration of solution means what? See here, the concentration of solution is defined as the relative amount of the solute present in a solution. Means how much amount of solute is present in a solution. For example, you have taken a 100 gram solution. Okay, both the solutions are 100 gram. But in first solution, what is the amount of solute is present, and another solution, what is the amount of solution is present? Suppose in first solution it is a 5 gram solute is present out of 100 gram, and in another 50 gram is there. So 50 gram is more, and that's why that solution will be concentrated. So basically you can see that on the basis of concentration solution, there are two types. First is diluted solution and the concentrated solution. And here I have already mentioned here, diluted solution means what? Here you can see that, see here the amount of solution is less, but the molecules are more. You can see here the blue molecules are, for example, solute. Blue molecules are the solute. So here you can see that the more solutes are present and the less amount of solution is there. It means that it's a concentrated solution. It is the concentrated solution. And in another figure, you can see that if I am adding water into it, then it will change the volume. Means the volume will increase, but by increasing the volume, here you can see that the amount of solute is remain same. Means in per volume, the number of particles or number of amount of the solute is becoming less. It means that it is a diluted solution. Okay, for example, you are given a concentrated solution and you want to make it dilute. So what you have to add? You have to mix with water. Okay, so it will be a diluted one. Okay, now let's see how you can express. This is very important. Methods of expressing the concentration of the solution. Why? Because without expression, how you can say that this is dilute, but how much dilute? Yeah, the number is required, and for that different expressions are there. And first of it, see the percentage by weight. Percentage by weight means what? Let me explain you. First of all, it is known as a W by W percentage, and it is defined as the amount of solute present in 100 gram of solute. Generally, we are taking 100. Okay, you can take 1000 also, but generally we are taking 100 gram because percentage is there. Okay, so here the weight of solute divided by weight of solution. Okay, and this 100 is in a multiply. Okay, this 100 is in a multiply. Okay, so weight of solute divided by weight of solution means both the side, upper and lower, we are having the mass. Okay, we are taking the gram, how much gram solute is there. For example, 5 gram sugar, 5 gram sugar. Okay, this 5 gram sugar is dissolved into the 50 gram of the solution. Means total mass of solution is 50 gram, in which 5 gram sugar is present. But both the side we are taking what? You have to see this one only. Okay, what we are taking? Gram. Okay, it means that it is percentage by weight, W by W. Now suppose we are changing the weight of the solution into the volume of the solution. See here, volume of the solution. So it will become percentage by volume, W by W. Okay, see, it is defined as the weight of solute present in 100 gram of the solution. Okay, what is weight is present? Okay, what is the weight is present in a solution is known as a percentage W by V. Okay, so here suppose I am taking 5 gram divided by what I have to take here. Suppose I am taking the 45 ml of solution. okay, into the 100. So what you have to see here again, 5 gram and 45 ml, okay. So it is known as a W by V. And the last one again here, remember this thing, remember this is I don't know why by mistake it is coming down, okay. So 100 it is in a multiply, here also 100 is in a multiply, okay. So volume by volume, you can also use this expression. So what is volume by volume? Let me explain. If we are having the 5 gram alcohol, okay, sorry, 5 gram instead of 5 I have to take 5 ml, 5 ml alcohol, and volume of solution, for example 50 ml, 50 ml solution is there, 50 ml solution is there into the 100. So it will give you the percentage volume by volume. Why? Because both the side we have taken ml divided by ml. So percentage volume by volume, percentage mass by volume, and percentage mass by mass, okay, weight by weight, okay, clear. Now let's see, next is the mole fraction, which is very important. And as you are knowing that you have already discussed and studied in 11th. So what is mole? Very important, okay. So it is defined as the ratio of number of moles of a component of the total number of moles of all the components, okay. So mole fraction, it is denoted by x. Mole fraction is denoted by x. And mole means, what is mole? As you are knowing that mole means what? It is represented by n, okay. Mole is equals to you can write W by capital M. This is the formula of mole, okay. Mass of the solute divided by molar mass of that solid, given mass upon molar mass, it gives a mole. And mole fraction means what? Mole fraction means mole, it is denoted by n, and mole fraction is denoted by x. So here the formula is there. For example, xa and xb. For example, we are having the solution of a plus b, okay. Solution of a and b. So if you want to find out the mole fraction of a, so it will be written as a xa, and if you want to find out the mole fraction of b, it will be written as a xb. And whatever you want to find out, of which component you want to find out, you have to take mole of that component, divide by total mole, Na upon Nb is the total mole, okay. So xa is equal to Na upon Na plus Nb. I can write here total moles, okay, total moles, clear it, okay. Similarly, xb is equal to Nb upon Na plus Nb, okay. And here very important, the total mole of all the component should be 1. For example, the mole fraction, the total mole fraction of A is equal to 0.6 and B should be 0.4. So A plus B should be 1. A plus B should be 1. So mole fraction will be always 1. Okay. Now next is very important, ppm, part per million. So part per million, see, a smaller part of solute in a million amount, okay. So it is defined as a part of the component per million part, 10 to the power 6 of the solution. And it is widely used when the solute is very less amount, trace amount. For example, in our at our home, the tap water is coming, and in that tap water the chlorine is present, some salts are there, so that amounts are very less. So we are using this expression, part per million, ppm, okay. So what is the formula? Number of part of the component into the 10 to the power 6 divided by total number of part of all the component. It will give you the part per million, ppm, okay. And it is used for the solution in which a very less amount of solute is present, trace amount of solute is present, okay. Now let's see next, molarity, important, very important. What is molarity? So molarity is the number of mole of the solute present in 1 liter. It is very important. 1 liter you have to take, okay. 1 liter you have to take, okay. I'm sorry, yes, 1 liter you have to take, okay. So it is denoted by capital M. And what is the formula? number of moles of the solute divided by volume of the solution. Volume of the solution, remember it. Okay, and if you do not want to write in a liter, see here it is in liter. If you do not want to write in a liter, you want to take in a ml. If you want to take in ml, then you have to multiply by the 1000. Okay, so the formula will be same, only you have to multiply by the 1000 here. Okay, and volume of the solution you have to take in a ml. Clear it? Okay, so molarity varies with the temperature. Okay, molarity varies with the temperature. If the temperature will change, the molarity can be also changed because volume is there. Okay, volume is there, so temperature if increasing, the volume will also increase, and if volume is increasing, see, the molarity will be changed. Okay, so it is not independent from the temperature. Okay, next, molarity is equals to, you can write the very important formula, solubility of particular solvent and multiplied by density into 10 divided by molecular mass. Okay, molar weight. Okay, so this is all about the molarity. Let's go to the next, molality, small m. Molality, small m. What is molality? See, instead of volume of solution, we have to just change here mass of solvent in molarity. See here, what is there in molarity? In molarity, you can see that the volume of solution is there here. Okay, mass of solute divided by molecular mass of solute, and volume of solution we are taking. Instead of that, we have to just take here the mass of solvent. Yes, you have to take in a kg, but if you are taking in a gram, then you have to multiply by the 1000. Okay, so molarity means what? Molality means what? Molality means number of moles per kilogram solute. Okay, you have to take solute, not a solution. You have to take solute, and here the mass is there. So when the solvent used as a water, then 1 molar solution is more concentrated than the 1 molar solution. Okay, because we are taking here what? Mass, and again it is independent of the temperature because mass is not increasing with temperature. So this molality is independent then from the temperature. No any change will be there if you are increasing or decreasing the temperature. So molality will be same. Next is normality. Again, the normality as same as the molarity. Okay, I will explain you how. See this formula here, mass of solute in gram divided by equivalent weight and volume of solution. In ml we have taken, you can also take in liter. When you are taking in ml, you have to multiply by 1000. And what is this equivalent weight? In the molarity, what was it? In the molarity, see here, it was the moles of solute. What was it? The molar mass was there. Okay, molar mass, molecular weight of the solute is there. And in normality, what we are taking? In normality, we are taking the equivalent weight. What we are taking? We are taking the equivalent weight. Clear? So this is the small difference, and you should know what is equivalent weight. So let me explain another formula. Normality is equal to number of gram equivalent of solute divided by volume of solution in a liter. So number of gram equivalent means what? Mass of solute in gram divided by equivalent weight. And what is equivalent weight? So equivalent weight means what? Molar mass divided by the valency. I can say as what is the charge of positive ion. You have to divide it. For example, let me give one example of HCl. Okay, HCl. So what is the equivalent weight of HCl? What will be the equivalent weight of HCl? So equivalent weight of HCl. So I have to divide it by the valency. So HCl's weight is 36.5. Because of the valency of positive ion is 1, I will divide it by 1. So the equivalent weight is equals to the molar weight of the HCl. But in case of H2SO4, in case of H2SO4, as we are knowing that the molar mass is 98. Okay, but here 2 H plus are releasing. It means that we have to divide it by 2. Okay, positive ion valency will be 2, H plus. Okay, so the equivalent weight will be 49. Equivalent weight will be 49. Okay, so for H2SO4 equivalent is becoming 49. So what is gram equivalent of solute? So mass of solute in gram divided by equivalent weight. So this is the equivalent weight. Clear? Okay, and now let's see last one here. Now here question is what is the equivalent weight? I have explained here, so let me explain you again. So what is equivalent mass? Equivalent mass is the molecular mass divided by n factor. What is known as n factor? See here, what is n factor? Formula of n factor. N factor is equal to molecular mass of the compound divided by number of ions, H plus ion, OH minus ion. Generally we are taking the positive charge. Okay, and the relation between the normality and molarity, this is very important for IIT JEE NEET. Okay, so n into equivalent weight is equal to capital M, means molarity, into molecular weight. Mole weight means what? Molecular weight here. And so we can write normality is equals to molarity into n factor. Okay, so this is all about the expression of different concentration. And finally, see here, I have written all the concentration into the one table. Okay, with the formulas, definitions, effect of temperature, where the temperature is affecting and where is not. Okay, and last one, the molarity, molality, mole fraction, and normality. All the comparisons are there in a one table only. So I hope you understood very well, because it is very important. All the formulas are very important for this chapter. So let me know if any doubt is there. Please write down in comment section. Thank you very much. Thank you for watching.